name is Valerie Peach. I'm working for Thermo Fisher as an applications specialist in the field of food extrusion. And before that, I was working at the university in Karlsruhe, where I did my PhD in meat analog extrusion. And today I would like to give you some insights into this very, very interesting topic at the moment. So before I introduce you into the technologies on how you can produce a meat analog product, I would like to give you first of all some insights into the meat analog market worldwide. So currently the consumption of meat analog products, as you can see on the slide, is governing one of the top trends on the food market worldwide. And therefore I would like to introduce you into some market numbers that you can see on this slide. So as you can see, for example, there has been a significant increase by about 14% of meat analog product launches, and according to many further market surveys, the meat analog market share is expected to further grow in the coming years. For example, what you can see is that Barclays Research Investment Bank forecasted that the meat analogs market share is supposed to grow from 1 to 10% of the global market for meat and will account for about $140 billion by 2029. So in order to be able to cope with this upcoming demand for meat analog products, we need processing technology that is able to produce especially meat analog products that have a muscle meat-like texture. And today I want to introduce you into this key technology, and I want to demonstrate to you our process 11 hygienic extruder, which is a modular lab scale extruder that can be used for quality assurance tests, product development, material testing, and formulation testing. And this allows you to tailor the product structure of your meat analog product at a small lab scale, and then later on transfer it to a larger extrusion process which you can use for the production of your meat analog products. So to be able to tailor your meat analog product properties to match the texture and taste of muscle meat, you can see on the slide the state-of-the-art extrusion process setup, which consists of a parallel co-rotating twin screw extruder. And the other main features of this process are that high water contents between 40 and 80%, depending on the protein that is used, are applied. And what we also need is a downstream cooling dyeing nozzle at the end of the extruder, which gives a very characteristic meat-like structure to the product. So now that we've talked about the principal process setup, I would like to introduce you into the actual hardware that we provide to our customers for this purpose. And here, of course, the main unit is the process 11 hygienic twin screw extruder, which you can see here is very small. It has a very small footprint. You can see here the control panel, and here the main processing unit, which is still open and not assembled yet. And here we have the liquid feeding pump for feeding water, and here a gravimetric twin screw feeder, which is filled with this pea protein powder, as you can see here, that will then be fed later during the process into the extruder. And when this material is fed into the extruder, it will be taken by these parallel co-rotating screws. These screws, as you can see, are existing of single elements that can be assembled together in order to conduct certain unit operations. And this special food screw design is assembled in a way that you can use it to feed material, first of all, with white throat elements that allow you to transport the material fast away from the material intake. Then it will be transported by the rotation of the screw along to the mixing zones, where the material is mixed, kneaded, and undergoes certain changes in its molecular structure, which are required to achieve the product properties of the muscle meat-like product. And then at the end of the extruder, the material will flow into the cooling dye. So now I want to show you how we assemble all these parts together, and then we will start with the process itself. So first of all, I place these two co-rotating screws into the extruder barrel. Like this. And then as the next step, I place the upper barrel part, which you can see here, which has the feed intake part here at the beginning and the liquid feeding port in the third part of the barrel. And as you can see also, we have a fully ported barrel design, which means that you could also at a later stage of your process also install another liquid feeding port, for example, for feeding oil or colors or whatever you can think of. So now that we've closed the upper barrel of the extruder, I will attach the adapter of the cooled slit die to the extruder and then the die body of the cooled slit die itself. Now, this is the die body of the cooled slit die, and here you can see the die has a quite short length in this case, because we also have a short, small scale lab extruder, and this die has the dimensions of 5 mm in height and 20 mm in width. So, and now that I've assembled the cooled slit die to the extruder, I will install also the liquid temperature control for the cooled slit die, and this can be done very easily, just simply by attaching these two pipes to the extruder. So now what we'll do next is to set the process setting by using this integrated touchscreen of the extruder. And here we start first of all with setting the temperature zones. Here you can see that we have 8 different zones that can be heated or cooled separately from each other. And I will start with what is called zone 2. To explain here, zone 1 is the feed of the material, and we start heating in zone 2. And here we use a low temperature because we don't want the material to burn right away. Then we start with increasing the temperature, and when I go on enter, I will go towards the zone 4. And here in zone 4 I will start going up to 80 degrees, so I keep this temperature. And then I will go to 100 temperature because we want to make sure that the material undergoes certain molecular changes, and for this we need a high temperature. And then for the rest of the extruder I will set the temperature to 140 degrees Celsius, which is a temperature that we know for this material works very well and gives us a structure of the product that looks like a muscle meat-like product. Now that I've set the temperature of the extruder barrels and the die adapter, I will also set the temperature of the cooled slit die. And here I will set the cooled slit die temperature directly. I can control it directly via the liquid cooling system. And here it is very important to mention that although we're talking about a cooled slit die, we use very often a temperature that is between 50 and 80 degrees Celsius. So technically we are not cooling, but here we often refer to this term because the temperature in the cooled slit die is always much lower compared to the extruder. So now that we've set the process temperature and started heating up the extruder, it takes about 5 minutes for the extruder barrel to heat up to the temperature that we want. And now before I can start turning on the extruder to process material through it, I first of all have to tighten all the screws to make sure that the barrels are completely sealed and to avoid that material could run out from the sides of the extruder barrel. So, and as the next step, now I want to start running the process. So what I will do first is that I start the extruder by letting the screws rotate, and then the next step then is that I start with the liquid feeding. And here it's important that we always start with the water, because this acts as a lubricant and avoids that if we only feed powder, that the extruder blocks. And then, after making sure that water is inside the extruder, which we see by water coming outside of the die, I will turn on the gravimetric feeder and add the powder to the process. So now we start hearing the screws rotate, and now that the screws are rotating, I just simply turn on the liquid feeding pump and wait until I see water coming out of the die. Now as next step that we have water inside the extruder, I will start the solid feeding at a very low feed rate, so at 200 gram per hour, while the water is feeding at 400 milliliter per hour. Now I wait until solid with water is coming outside of the die, and then I will adjust all the process settings to the range where I want them to be. So after about 5 to 10 minutes, we have reached stable conditions with the extruder, and you can see that the product is coming out of the extruder. Right now, the extruder is operating at 780 milliliter water per hour and 520 gram of powder per hour. And so we have a total throughput of 1.3 kilogram per hour. And at this point, so before the material enters the die, it has a material temperature of about 130 degrees Celsius. So, and we see here that the product is flowing out of the extruder. It looks quite smooth and slippery, which is due to the high water content. Now, when I cut the product from the die, I want to show you how fibrous and well textured it is. And this you can only see if you tear it apart. And you see that it does not tear in an isotropic way, but in an anisotropic way. And it also shows fibers, which you can see if you tear it along the flow direction very carefully. And you see the fibrous structure of the meat analog product. Now, of course, if you just look at the meat analog product just by the view of it, it's difficult to compare different meat analog textures and material formulations or processing conditions with each other. And for this, what I would do next now for analysis is that I go into our lab and analyze the microstructure of the meat analog product using our scanning electron microscopes, and also to get a quantitative quality measure, I will go and use our rheometers that allow us to measure the texture of the meat and milk products and get a quantitative value that we can use to compare the characteristics of these products with each other. So now I have introduced you into the high moisture extrusion process and how you can use this process to produce meat and milk products. I also hope that I was able to give you some detailed insights in how we as Thermo Fisher can help you with our production equipment, but also analytical equipment to produce such meat and milk products and analyze them later on. And with this, I would like to thank you for your attention, and if you're further interested in this kind of applications, but also other food extrusion processes, please feel free to contact us. Thank you.